discuss migrating Azure Resources to Terraform. Before we start, I just want to quickly introduce the speakers. My humble self, my name is Ihana Chochukwu. I'm an infrastructure as a code principal engineer. I'm also Terraform certified. And we also have Chidi, who also have tremendous years of experience in this field. Chidi, you want to give us a shout out?
Yeah, thank you, Nacho. My name is Chidebere Ugu, Senior DevOps and Cloud Infrastructure Automation Engineer. Today we'll be giving you a walkthrough on migrating Azure resources. Please stay tuned.
Yeah, thank you for that introduction. I will try to kind of rush this over really because we've actually had some technical issues that led to some delays. Quickly want to have like kind of introduction to Terraform. Will I really say introduction? We've been on this topic for quite some weeks now. IAC, talking about biceps, bits with Terraform as well. We talked about AKS and the rest of all those kind of deployments. So it's more of like a continuation. I will just briefly talk about the benefits as well of using IAC. Then we'll go through to the topic of the day to migrate our resources to Terraform really. So let's get the ground running. So basically, Terraform is an infrastructure as a code tool used for deployment of resources using the declarative approach, meaning that you get to define the desired state of an infrastructure, and Azure or whatever platform helps you to get to that desired state. And Terraform supports multiple providers: Azure, AWS, Kubernetes, GCP, a lot of cloud technologies and providers in general. Why IAC? IAC can be version controlled, meaning that we have all our configurations deployed using likes of like Git, meaning that we can track our code changes. At the same time, we can really get to understand that things are really cleaned up, right? It helps to manage our deployment in a flexible manner and also helps to account for all our resources. It also has good reusability of code, meaning that we can have the likes of modules, templates, and really keep our configurations in a very cleaned and tidied manner. So it's, of course, automated provisioning and management of resources. We have this defined in HCL, and we can get to our desired state really quick and fast. And we can have all of these integrated into automation pipelines, CI/CDs like Azure DevOps, GitLab CI, GitHub Actions, okay, and the rest of that. Looking at the benefits of Terraform, really, we've already talked about so much of them, but definitely we're looking at consistency and ability to reproduce our configurations. Meaning, if we have automated a process, say in like a development environment, we can easily move that to staging environment or make a little bit of changes, and it's all tracked and it helps things to really be tailor-made to an environment, avoiding human errors, and helps us to also make easy scalability. With just changing one configuration, we can really get to a different entire configuration. And since we are using technologies like Git, kind of helps us to be able to collaborate with different teams, really, different individuals. Different people can work on different features to improve, add more features to their infrastructure, really. Then in terms of costing, because everything is properly managed through configurations and Terraform config files, that means that we can avoid idle resources, right? If we know about the resource being deployed, we can as well determine if that's needed, and if in eventual case we need to delete that, it can easily be tracked. So it helps us to reduce costs because we don't have orphan resources lying here and there. And also, since it helps us better manage our resources, it definitely impacts on our cost of releasing applications that will eventually use these infrastructures. And now we'll come to the topic of the day, migrating to Terraform. In traditional deployments, we have other ways of deploying resources. Say, for instance, one could want to use the GUI, that's the portal, like, for instance, the Azure portal, for instance, and that resource has previously been deployed somewhere. Okay, probably it's been done with PowerShell, Azure CLI, or whatever means it is that is outside of Terraform, right? This creates a need, probably where we want to enjoy the benefits of Terraform, and we want to start migrating to a more professional way of deployment. We might start considering using IACs like Terraform, which are very declarative, right? To enjoy the benefits of Terraform, it simply means that we have to find out a way to manage our resources to use Terraform. What do we do for this? We need to understand the resources we want to migrate to Terraform. We need to identify them, and this could be virtual machines, database, storage accounts, and as well as consider any dependencies. Okay. So whatever we want to migrate to Terraform, we also need to look at, does it have any dependent on any resources that as well need to be moved over to Terraform? We also need to consider the impacts of this migration. And ideally, if it's done correctly, there shouldn't be any changes, which means that the impact really will be reduced. Okay. So if there's no changes, then we're looking at only benefits. But if there's changes, we may need to really consider that, so you don't get to a point that you delete resources or you make unnecessary changes or undesired changes. To use Terraform, we need to as well have the prerequisites. We need to have Terraform installed on our managerial environment. Okay, be it on pipelines, be it on local environment. We need to prepare that environment for Terraform use. Also needs to have the likes of Azure CLI installed, so we can authenticate to Azure. We need Terraform, and we might as well need Git, so we can carefully track our changes as we try to make them. So we also need to consider the state management strategy. This is more of like deciding where to host the Terraform state file. And now, what is Terraform state file? It's more of like, the essence or the store of the Terraform configuration. It carries the representation of our environment in Terraform store. Okay, that has to be a backend, which could be local or remote. It's ideal to like import in, when you are trying to import it. Sometimes we want to start with a local state and move this to a remote state. But whichever strategy that is to be decided on top, we need to carefully consider its benefits and have a strategic way of moving this over. And also in terms of doing this migration, we look at the effects in terms of starting from a lower environment. Of course, you shouldn't, just move to production. So we ideally want to minimize the risks, meaning we'll start from a lower environment, say some labs or some development environment, and gradually move this to a staging environment, a UAT environment, QA environment, till we get to a production environment, right? And also there are many strategies to also consider. Do we just move this over, or we move this to modules? Like, all the strategies that needs to be implemented has to be carefully organized. Now, what are the best practices for resource migration? We start with non-technical resources, like we mentioned. So we start with a lower environment and we migrate to a higher environment. Then we can as well break down the migration into phases. We can move from a less complicated resource to a higher resource. And at the same time, we want to consider probably representing this first in what we call just like a resource block and simple kind of arrangement. Okay, first get this to a configurable state. Then you can now look at ways to further improve it, say using the likes of modules or using templates. Okay. We also need to consider version control and review, meaning that as we make the changes, we want to start from a very small resource, commit that change, add more resources, commit the change as well. So it's going to be a more of like a progressive approach. You don't just maybe you want to migrate, talking about like say 5, 6 resources. I want to do it on a go, or probably have like 50 resources. If you do it on a go, it's gonna be too complicated. So you're gonna start with piece by piece, and you fit in all the pieces together. Of course, we have to test this in an isolated environment. Start local, move to a more higher environment, really. Start from your lab, move to development, and move to higher environments. At this point, I'll want to give the floor to Chidi, my colleague, to give us an overview of how we can do this in practical terms. A lot of theoretical way of doing it, so let's get down to business. Chidi, do you want to take over?
Yes, thank you for this comprehensive overview of migrating Azure Resource to Terraform. So basically, there are different ways which we can achieve this. We can implement that using some third-party tools. We can also implement that manually using some Terraform command, importing the existing resources and then managing that on TF state. Also, we can implement that via CI/CD pipeline. So, but today with this demo, I'll just give a walkthrough of how you can implement it using manually importing the resources from Azure, and secondly, automating that via a CI/CD pipeline. So please let me know when you're able to see my screen. Are you able to see my screen, guys?
I can see your screen.
Okay, good. So here with me is a basic Terraform resource configuration and the YAML script that we use to test the CI/CD pipeline deployment. So what I'm going to do is I will navigate to the Azure portal to show you the resource which we are going to migrate. This resource, okay, this is the resource. So in this demo, we'll be migrating this key vault. This was deployed using a graphic user interface, this Azure portal, and then we'll be migrating it to Terraform to be managed by Terraform. And also the TF state will be installed on this storage account that we have here. Yeah, the TF state will be stored in this storage account. So let's just get started. Then the first thing to do when migrating your resource from Azure to Terraform is to declare the resource block. So for instance, here we are importing the Azure Key Vault. So we have to declare the resource block, which is Azure Key Vault, and then specify the name of the resource which we are importing, the exact name of the resource which we are importing, which is this. Then also we declare the provider, which is Terraform, the Azure RM Terraform provider, and then specify the target. So it's not the best practice. You need to implement the encrypt this on either a key vault or maybe a group, library group or variable group in Azure DevOps environment, or better still, export it locally. So, but for the purpose of this demo, we'll just leave it this way and then encrypt it via the pipeline. So this is the resource declaration. So the next thing to do is we'll do a Terraform init and then import that, so that we'll, from the import, the TF state, we'll be able to specify the values of this. So in that situation, is assumed you have not created your variable.tf, your terraform.tf values, or your backend.tf. So the output of the TF state now will give you more details for you to use to populate this. So at this juncture, I will do a Terraform init, or better still, I can start with listing the resource on this target resource group to make sure that we are importing the right resource. This is a particular resource which we want to import that exists within this resource group named Chide. So if you are trying to do this locally as I'm doing now, and you have not authenticated to Azure Portal, the first thing to do is to do AZ login. And this will take you to a browser interface where you sign in with your credentials to Azure interface, or you can as well use a service principal depending on the authentication method that you have implemented. So as I've done this, the next stage is to do a Terraform init to initialize Terraform to this directory. I'll do a Terraform init. Okay, good. Coming up. Okay, good. So with that, the next stage is to import the Terraform before planning. So I've also written down a script on importing this. You can export the variables using these commands, export that locally on your environment. So here, for the purpose of this, I'll just go straight to import. Explaining this script, this is a Terraform command, Terraform import, specifying the resource, and then this specifies the resource, and this specifies the resource ID, which is the subscription ID, the resource group, the name of the resource, and then the provider, which is keyvault, and the name of the keyvault. Once you run this command, you should be able to import this from Azure Portal to your local environment. So let's just give it a few minutes or seconds. So I'll also show you how you can implement the same import via a CI/CD pipeline, but that should be a second stage after this. Okay, good. Okay, Terraform import successful. So with this Terraform import, we can now take a look. Yes, we can now take a look at the TF state. So from the TF state, there are key informations that we need to pick from the TF state to use it to populate the variables or the dependent variables within this resource block. So one of which is the resource name. Okay. So here you have the storage accounts, the resource group name. Then we have the storage account name where the TF state is stored. We have the container name. All these are initialized in the variable, but this just show you how I got those details. So you have the resource group, the storage account name, the container name, and then other details down. Then depends on good. So now with this information, you come here and specify. Okay, let's check. Also, we should have the location here. On the num, it should put the location attribute at the same time. So by this command, okay, it didn't get that, it put that to null. However, it will populate again to get the location attribute. So in a situation whereby you run a Terraform import and did not get all the details required here, like the location as I'm checking in here, you can go to the resource itself, which we are trying to import, and check that, which is UK South, and the name of the resource. And you populate that on the resource block, which is the name, the location, the resource group name, which is in the TF state, tenant ID, and then the SKU name. So you can get some of this also apart from the TF state, you can get it from the GUI interface. So you can get the tenant ID, which is this, the directory ID, then the SKU, you can also get that here on the settings. So yes, this is the SKU, which is standard, this is the location, so this is the name. So if you don't get the values displayed on the TF import from the command, then you can get those variables from the settings of the resource that you are trying to import. Then the next thing to do is, after you have done this, populated this, you can as well go further to fine tune your code to initialize them as variables, and then put the values of these variables in your TF verse. This is just to make your code more readable and more manageable, but you can still have the values directly implemented here. So having done that, then the next is to do a Terraform plan. A plan of this will show if there's a modification to do and all that. Okay, so this is showing a missing argument. Let me troubleshoot that. Just a minute. Okay, let's see resource this from the more. Okay, the resource group name was found. Okay, I have the resource group name. Missing required arguments and the tenant ID. Okay, which is this? Yeah. Then I have the name, which is this, the location, and the SKU name. Okay, pardon. After I have done this, I have to reinitialize this to be able to pick these values. Okay, good. So yes, after you have picked all those necessary variables and implemented that either directly from here or making your code more readable by initializing variables and Terraform tables. So you have to reinitialize your Terraform to pick those values, and then you do a Terraform plan. So the output of the Terraform plan is showing that there is one update, which is this. So, which is enable airbag authorization. It was true, but it should be put to no because I did not specify an airbag authorization here. So this value was true in the Azure portal, but because I didn't specify that here explicitly, so it will be no. So from this, you see that 0 to add, there is no new configuration to add because we just imported it, and then 1 to change, which is only this update, the airbag authorization, and then 0 to destroy. So if we run a Terraform apply from here, then this will deploy, and then you see that this particular resource will be managed by Terraform. So let's take a look at the way we can implement this using Azure DevOps Pipeline. So this is the output of this, and that's it. So let's go to CI/CD pipeline and implement some. But before I proceed to that, I'll give a general explanation of the CI pipeline script that will perform that action. So within the CI pipeline, so we have our trigger, which is the main branch. So once we commit in code from here to the main branch, it will trigger the pipeline. So we're using Azure Pipeline Agent that is managed by Microsoft, and the image name that we're using is Ubuntu latest. So you can use any of your desired image like Windows or any specified version of Ubuntu. You can also implement self-hosted agent if you have a self-hosted agent. So in our previous videos, we showed how you can create a self-hosted agent on that. Then this is a variable group. So instead of initializing all this backend.tf and the whole of the script that might expose your details, you put them in a variable group. So this is a variable group. I'll give you a walkthrough on that here. Yeah, on my Azure DevOps environment, you come to, you navigate to your DevOps organization, you select the project that you are working on, and then you go to pipelines and scroll down to libraries. So within the library, I have this variable group named. If you open it, you see all the necessary variables that we use in the pipeline. We have the service principal ID and secret. We have the subscription and the tenant ID. We have the service connection, which is this. We have the container name. We have the key to the container. We have the resource group, and then you have the storage account. So these are the variables that we're going to use. So instead of initializing all this within this interface, okay, let's navigate that from here. So instead of initializing all those variables in here, so we have to specify them under a variable group and just call the name of the group. So the next step is you state the jobs that you want to do to import the Azure resource. So the first step is authenticate. How do you authenticate? Using a service connection. So the service connection has visibility between Azure portal to Azure DevOps environment. Then we have to show the AZ account show. This is just for troubleshooting purposes in case you have errors in authentication or so. But in a live environment or production environment, you don't need to show the account details. Then the second stage is to install Terraform, which is required by the Terraform version that we're using. And then now we initialize. After installing Terraform, we initialize Terraform. This is the actual command that performed the Terraform init, and then we specify the default working directory. If you have your code base in a different directory, you can specify that from here and then specify the path. Then we have the backend type is Azure RM. We specify this is the service connection. This is the resource group, the storage account name, the resource group and the storage account name, and the container. All these variables are from the variable group which we have initialized. Then the actual script to import. So within this import, we have the command which is import, but then the same variable that we've initialized before, the working directory, the service connection, then optional commands specifying the subscription ID, the client secret that has permission to deploy to that target environment, and the rest. So the two major parameters in here is this, the resource address, which is Azure RM Keywords Terraform Migrate. That's the name of the resource that you want to migrate, and the Azure RM resource name. Then the resource ID. You have to copy the resource ID from this interface and this. Okay, so you can get the resource ID either from this is the simplest way, from the subscription ID to the resource name. Yeah, this is the resource name. You can copy that from here, and then you now modify. But if you copy that from here, note that the subscription here is encrypted. So instead of putting the subscription ID in a plain format, then we have initialized that on the library. So which is this, so you call it as a variable in here, and then this will import that particular resource. Then This is the Terraform plan. After we have imported, this will give you the plan output of what you have imported with the same variables initially stated. And then you can now do your Terraform apply. So this commented section basically is in case if you want to import multiple resources at the same time or in modules, there are different approaches to that. One, you can use Terraform task like this Terraform task, this Terraform task. So you can use Terraform task to import the resources. Okay, this is for apply. You can use Terraform task to import the resources. As you can see, Terraform import key vault 2. And then also specify the resource address of that second key vault or any desired resource we're talking about. And then the source, the ID, the resource ID of that particular resource. With this method, you can use multiple tasks to import multiple resources, or you can use a script to loop into multiple resources. This script here can now declare multiple resources. As you can see, key vault 1, key vault 2, right? They migrate vault 2, migrate vault 1. So this must not be vault. It might be individual resources like virtual machine, public IP addresses, storage accounts, and the rest, databases, depending on the resource you want. So you specify those resources here and use a for loop to loop into all those resources, but also specifying the credentials to authenticate. So this will now loop at each, and at this cut, this will end a particular loop at, at the column and then enter a different field. And as it enters a different field, it will loop and end that within individual column and then continue. So irrespective of number of resources you have, as you have here, it will loop differently into each and every one of those resources, and then referencing the client secret and the credentials need to authenticate. So in that situation, you'll be able to do multiple resources using a single pipeline. But for the purpose of this demo, we are just importing that particular key vault and then deploying that. So with this, let me trigger this pipeline and then we do a run on this. So okay, let me authorize. There is some authorization. Approval pending here. I've done the authorization. One approval needs review before. Okay, there is still a second approval. Okay, which is this? Okay, let me reassign it because I won't be able to log into that now to save time. So I've reassigned it to this particular user and then approved it too. So let's see how the pipeline runs within some seconds. So if everything is fine, the output will just be similar to uh, what we have here on the local environment, and that shows the configuration is the same. Terraform initialization. Here the actual Terraform import. Okay, a Terraform plan. Let's see the plan output. Okay. Okay, from what we can see here, the plan output is exactly with what we have when we did the manual import. So this shows that the configuration is fine and only one update will be done. So if maybe there is an addition to this configuration file locally, if there's an addition to this configuration file locally, then there will be a plus sign indicating there will be an addition. Then but here is this which shows there will be an update, not a total deletion or uh, or an addition, but an update changing this from true to this. So the next stage after this is, if we want to actually deploy this immediately, is to uncomment this apply path, and then once we uncomment this apply path, then we'll be able to trigger that and apply that to the resource. This might okay. That's just all about that for now. This might not go based on the permission of the service principal on the target Azure environment. But let's just see how it works. Review the approval again. Check. Okay, reassign this to a new person to approve, and then review and approve this. All these protocols just to make sure that you don't deploy a wrong resource to a wrong environment or target subscription. There's excess of approvals. Yeah, there will be a right permission issue here, but this is just for a demo purpose for you to understand how it works, how you can import it locally, and how you can import it using your Azure DevOps CI/CD pipeline. So, having said this, so on at the end of this video, I believe my colleague will be able to show you our repo so that you can fork any of our repos and use it for testing purposes. Okay, good. So this is what I mentioned. This keyword on this subscription. Let's go to the error message. You see, service return an error, still insufficient permission. Yes, I've already tried that. So the permission method follow for this is the same. Authorization role assignment right. So this particular service principal with object ID cannot write against the subscription, and that's just it. So if you have full permission on your environment and you assign the service principal roles to be able to deploy, then you perform the deploy on this and then everything works fine. So but because of that, we are not proceeding to uh, run the actual deploy. Let me go to the service principal and show you how you can actually get the service principal name, and then you can troubleshoot from there or maybe assign a role to it. So I'm searching that with the object ID, which is this service principal. We can check. This is the overview. Okay. Then the next thing is on the target resource group where we are deploying this our resource, we can actually go there. This is the resource. This is the target resource group. So you can assign role to this if you have the permission. Come to access control IAM. Yes, do new role assignment. And then select keyword admin. Keyword administrator role. And then if this works, you can select the particular service principal. If you search by the object ID, it doesn't show you type the name. So you can select this service principal and then click select. If it works, then the deployment final will go. So, but for the purpose of this, I've tested that and the role assignment is not actually working against the subscription. So that's it for now. So at this stage, I will hand over to my colleague to give more details on maybe any other tool that you can use to do a Terraform migration. And then in absence of none, then we'll entertain your questions and do where to address them. Hi, Nacho. Are you there?
Yes, I'm here. Thank you for that detailed explanation to Terraform importing and how we can migrate existing Azure resources into Terraform to be managed by Terraform. In terms of other tools that are available for use to do this same importation, I've come across Terraformer and AZ to TF utility for migration. But really, kind of like the way you walk us through this traditional way, because then it allows us to understand each workflow and how to really do this in the simplest way we can. We will not cover that in this demo, really, but it's worth mentioning that we also have Azure to Terraform, which is short known as Easy to TF and the transformer. Yeah. So because sometimes there are kind of unique challenges, struggling to import each resources one after the other, especially when you have a whole lot of so much resources, you might want a lesser rigorous way of doing it. So we won't cover that in this demo, but it's just worth knowing about that. Thank you. Is there any question we want to ask so we can look into that? Leaving the room for questioning.
Yeah, feel free to ask any question you might have on this.
So, well, there is no question. That must have meant that you actually did a thorough work in explaining all of that, importing the state to the TF state. And we can try to emphasize that we have other communities you can be part of. We have community presence on LinkedIn. We also have a GitHub repo where we try to push in all our code for each event into. We can share that on LinkedIn as well, so everyone gets to see it, and whoever wants to probably fork or gets to ask more questions on the community channel is free to do so as well. And after this session, we also move this recording to our YouTube channel, so you can follow us for more content and also have opportunity to review the past events as well. So my colleague is sharing the repo on his screen. So we have the Azure Infrastructure DevOps Support Community GitHub user, which hosts all our repositories. So we have the ARM templates migration here. We have Kubelinter, we have Bicep deployment series, we have Terraform migration. We have all of these in this place, and feel free to fork and play around with it. So we also have a WhatsApp community group where we as well try to share informations and ask some questions as well. So first, we're talking about Azure infrastructures will be very handy to provide support in related fields. Guess it's time to really appreciate everyone for being here. And if there are no questions, Daniel is raising his hands up. Okay, Daniel, you have the floor.
Oh, okay. Thank you very much for such an insightful presentation and walkthrough. I'm really happy. But my is what's it called? We'll be happy to get the various links to the WhatsApp, the YouTube, and probably the what's it called? The GitHub repo, so that to come handy to us. And if there's any problem we are facing, just try to put in our answers to any group that we within the group, so that we could also learn from that. Yeah.
Okay. Okay, that's great. But how do we are you following any of our channels now, so that once we share the WhatsApp group, you'll be able to get it from there? Are you following us on LinkedIn?
So I'm following you guys on Meet, but I don't know whether you have what's it called, a LinkedIn channel or even a YouTube channel. This is my first time actually hearing about.
Okay.
Maybe I've subscribed to your LinkedIn channel, but I don't really know. So
Oh,
maybe
okay.
as you're opening it, I would get to know whether if I've subscribed to your LinkedIn channel. So
This is the LinkedIn group we're talking. So we can follow every of our activity. We have another event tomorrow, so we can follow every of our activity here. And the next post we are going to do based on this session that we had, we'll put on the WhatsApp link as well in it. Is there any other question from the audience or maybe from Daniel? Is there any technical question for us?
For me, I'm okay. I'm kind of I will not say new to Azure, okay, but I still want to get more experience within Azure, and it's how to use it to help in the cloud space. So um, you really opened my eye to certain things that I didn't know, and I'm so happy and grateful for that. And one thing I'll do is I just refer to LinkedIn channel and try to learn new things that I don't know, or try to relearn what I knew in the right
Yeah.
way.
Yeah. And if you have question along the line, then don't hesitate to drop your question. Okay, thank you. Nacho, are you there?
Okay, sure. Okay,
Yeah,
sure.
I'm here. Thank you very much for the interaction, Daniel. I really appreciate that. So we again tomorrow we have another session, a very exciting session on GitOps, using GitHub with Argo CD to manage application. And we as well will likely want to extend this to infrastructure as a code as well to manage resources within Terraform, within Azure using the likes of Crossplanes. So it's going to be an exciting series. Might be a little bit of new concept to some persons, but yeah, we'll do our best to walk you through this and make sure we have a very engaging and simplified session. We'll see you guys tomorrow again. Thanks for today and all the time.